this. All right. All right, hello everyone. Thank you very much for coming to our talk about Finding the Needle, a deep dive into the rewriting of Haystack. I'm Tuana. I am in the developer relations team at DeepSet. DeepSet is the name of our company, and Haystack is one of our products. It's an open source product, and we're going to be talking about Haystack today. And it's not just me talking. I'm also joined today by Massimiliano Pippi, who is the lead for the open source engineering team. So we're going to do a switcheroo. There's going to be parts where I talk about Haystack, and there's going to be parts where he talks about Haystack. But to give you all some context, I'm really hoping the GIFs in the next slide work. This whole talk is about how we transformed our framework that was very functional, but at times a bit complicated to use, to something that's maybe a bit more smooth sailing, and hopefully we've done a good job of it. And today we're mainly going to be talking about our pitfalls. We're going to be very brutally honest, and we're going to be talking about how we then changed Haystack. Quick recap, although it's really not very important for you to know anything about AI for this particular talk, Haystack is an open source AI framework to allow developers to build their own AI applications, making use of different language models and language technologies. And you can think about, in this case, you can think about question answering and chatbots and document search, all these types of applications. And Haystack is basically a framework. It's a way of building these types of applications. So a bit of context around Haystack and a bit of history. I'm going to go back into the history in a bit. But Haystack was first released in 2020. And in 2020, Haystack was implementing some of the most common use cases in AI at the time, which was search, retrieval, question answering, and for anyone who knows NLP, think extractive question answering. So we weren't really doing much with generative models. Then 2022 rolled around, and I'm sure you're all aware that 2022 changed the way we operate and we work with language models quite a bit. Now, this is not to say that generative models didn't exist before 2022. They actually did exist. But 2022 was quite a pivotal moment because it was when OpenAI released ChatGPT, and people realized just how performant these models are, which also changed the way we actually make use of language technology. So I want to give a few examples of how things changed. I already spoke about extractive QA. It's fine if you don't know what that is, but when 2022 rolled around and we were able to use models like GPT-3 and then following that GPT-4, the way people started to use these language models were really based around instructing a model. So in this case, you can see here, I've got an instruction, given the documents answer the question and documents in question. You would still be able to build question answering systems, but you were instructing a model and you were asking it to reply to a question based on text. You could also maybe do other things. But then it also turned out that when you're a developer building this type of stuff, you have some requirements. For example, nowadays, maybe you don't want to use OpenAI. Maybe you want to be able to switch that with another model. You can go further. Maybe you don't have an easily pre-processed set of documents that you want to answer a question on. Maybe you want to access all that data from a database. Maybe you want to do vector search, and so on. We also saw that actually, while there were models that were very specific to a use case, for example, you would have, if you were on Hugging Face or any type of index of open source models, you'll see that there are models that are specific to summarization, that are specific to translation, that are specific to question answering. It turned out with these new very performant large language models, you could actually do a lot of these just by changing the instruction. And we're still seeing this today, right? We can instruct the model to do question answering, summarization, question generation, and the list can go on and on and on, honestly. But long story short, what does that look like if you were to try and build an application? So I'm sure some of you have already heard this term millions of times before, retrieval augmented generation. This is one of the most common applications we're seeing people build with AI technology these days. And long story short, it boils down to two steps. It boils down to retrieval. And again, you probably want to have the freedom to decide where you do that retrieval from. Maybe you want to store your data in Chroma, maybe Weaviate, and so on. You also then have to do some type of generation. And again, you want the freedom. Maybe you want to generate with OpenAI, Mistral, Gemini. Again, the list can go on. But in reality, it's not just this simple. You don't just have retrieval and generation. Often cases you have quite a few requirements. A very simple one is maybe you have to retrieve and then re-rank. Maybe you have to really make sure that the documents you've got are the most relevant. And I'm going to stop here. Obviously, this pipeline or this what you're seeing here can get quite complex. But already, maybe some of you have already started to notice what this kind of starts to look like. We're talking about steps that each do something to data and then forwards that data to the next step of your AI application. So what we call this is a pipeline, and a pipeline is a component forwarding data to the next component. This is really what Haystack is based on. And we're also seeing that these components, depending on what you want to do, can be components that does text embeddings, component that does retrieval, prompting, queries a large language model, maybe some classifiers, maybe some re-rankers. Again, the list can go on and on and on. So there's really nothing to say about what a component should or can be. It could literally be anything. It depends on what you're building. So I'm going to wrap this up and then hand over to Massi, a little bit of history behind Haystack. So you've seen now that how we see people build applications is really about forwarding data to the next task. And when Haystack was released in 2020, it was really focused on this concept of components and pipelines. The thing was, the pipeline structure, or let's say the ethos behind the pipeline, was still quite centered around technology that was around extractive QA, search and retrieval, not necessarily expanding itself to the use of large language models and prompts. So there were a few things we noticed. It turned out that this pipeline component approach actually does translate really well. It does really the abstraction helps building with large language models and prompting. But there were some things that we had to change. It turned out that some of the assumptions we made for language technology back in 2020 didn't really prove to be good developer experience once you started to work with large language models. And there were some pitfalls and mishaps. So with that, I'm going to hand over to my colleague Massi, who's going to talk about what we did wrong. And I'll give this to you.
Thank you, Tuana. Yeah, I have this thankless job of telling you what we did wrong with the first version of the framework. To keep it simple, I kind of collected all the problems that we had into 4 macro categories of bad design practices. And I'm going to give you a few examples so you can all understand. Let's start with the first one. This usually goes under the name of overexposure, is when you put some extra cognitive load on the client of your public APIs. So you ask for way more than data that you should actually need. Now, take this example. It's a bit small, but yeah, you don't need to grasp it exactly. This is a class called embedding retriever. And usually what an embedding retriever does in AI applications is querying some sort of vector database, passing a query, getting back some results. So it's something that retrieves. And now, set aside for a moment the fact that this constructor takes like a couple of dozens parameters, which is a problem in its own. But if I zoomed in a few details. So if you go through the list of parameters, you find use GPU. It's a Boolean flag, yes or no. Fine, I get it. Sometimes you want to use your GPU to accelerate queries on vector databases. Fine. Then you scroll down, and at some point you have, you can pass the list of devices, and devices are your own GPUs. So like, okay, if I'm passing you the devices, well, why should I tell you if using GPU or not? Use it. But it can get worse. You scroll down again, and at some point you find a bunch of parameters regarding Azure. So like, okay, I have my own GPU. What's Azure for now? But it doesn't matter because you scroll down again and you find that the default URL for a parameter called API base points to OpenAI. So, another category of pitfalls or design mistakes is called special general mixture. So this happens when you try to make something generic, but you fail actually making it specific to something. This is a method, not a function. This is a method of the pipeline. As Tuana said, a pipeline is supposed to achieve different use cases, right? And run is the way you trigger a pipeline. You begin the workflow. I'm giving you some input, give me some output. Run. Being pipelines very different, it makes sense to have a generic run method. We want a run method that works for pretty much any use case. Good idea. Too bad this is not what happened, because as you can see, the parameters that you have to pass to the run function are not very generic. They belong to different domains, so you can pass a query, but you can also pass file paths. The query makes sense for querying a database. File paths make sense if you want to fill the database with data. And then you have documents, that's basically the in-memory version of what you would have on a file. And everything defaults to known, so you could actually call this method with no parameters. That would work. We have no idea what would happen. Another category, information leakage. This is actually, I think this is the most important. When you write software, you absolutely want to avoid any kind of leakage. Let's see an example. So what do I mean with leakage? Say, there are different types of leakage. In this case, we have a bunch of abstraction layers. So you build one layer on top of the other. You try to abstract away a few details. But you make the mistake of leaking details from different layers to another. And this defies the original purpose of isolating things. In this case, again, it's a bit small, but you don't need to read it. We have a class called prompt node. And from the name, prompt has something to do with LLMs. Fine, you open the documentation, you find the prompt node class documented. OK, I'm going to use this thing to query a generative AI model. Fine. Then you scroll down, and you find that the model name can be a string. OK, makes sense. I can pass the name of the model. Or a prompt model, which is another thing. So you go and check it out. What's this prompt model? Again, you go through the documentation, maybe through the code, and you find this other class, prompt model. Fine. And then there is the model name again, OK? And you scroll down, and at some point, you find invocation layer class, which is another class that now you have to go and fetch and investigate what it does. Do I need it? Or I don't need it. Another category, I call it conjoined components, but yeah, actually this is about having one job and failing at it. I brought back my embedding retriever class. So again, it's a retriever, it's supposed to retrieve. So you go through the list of the methods of the class. There is a retrieve method. Fine, a retriever retrieves, makes sense. Then you scroll down, embed queries. Oh, now this thing that's supposed to give me things, I can use it to put things in, embedding things, I don't know. And you scroll down, embed documents. Oh, is this different from embedding queries now? And you scroll down again, and you find train. OK, should I train the retriever, train the underlying model? I have no idea. I have one last example, but before going through it, I need to teach you in 30 seconds how Haystack pipelines are made. So usually, you start with the instantiating this pipeline class, which is empty, the first line. And then you add the nodes. Remember the picture that Tuana showed before. You have one node after the other. And you add the first node. In this case, the component is of type retriever and has a set of inputs. And one input is this query. OK. Another component, the prompt node that we have seen before, another set of inputs, fine. Finally, you run the pipeline. You actually put this in action. And in order to run the pipeline, you have to pass what the first node requires in input, which is a query. Fine, it's a retrieving pipeline, so I can pass a query. What does the road statue look like? Give me the answer. So far, so good. But as Tuana said, you can have different types of pipelines. So say now you have a long text that you want to summarize. Again, you create an empty pipeline, and you add the node that's called the summarizer. So this node will be responsible to take this text and give him back the shortened version. But once again, if you look there, you have to pass a query as an input. And now I'm confused, like a query for a summarizer? And when you run it, you have to pass that query. And that query will be ignored, of course, because it doesn't make sense. It's a summarizer, you're not querying anything. So this is just not needed, but it's mandatory. And the actual parameters are what you see in the last line, the generation quarks that you pass to the actual summarizer. And that's it for now. Let's give a positive turn to the talk. I'm going to pass the ball to Tuana again, and so she can tell what we did differently with the rewrite.
I like that I only have the positive notes in this presentation. Okay, so you saw that there were some problems with Haystack 1.x, even though, let's be honest, it was still quite functional. And there are still people using Haystack 1.x, but we decided that with the new large language models and the new way of interacting with language models, Haystack really needed a rewrite. One thing that we kept was the concept of pipelines and components, because, like I said, it really did look like the abstraction was going to translate well into the new era of using language models. But we made some significant changes, starting with components themselves. So you saw how Massi showed you that there's a special general mixture, conjoined components where it's not sure exactly what the component is supposed to do, it's doing more than one thing. We really focused on having components that are responsible of just one thing only. We also made sure that the components themselves were very descriptive. So this is a mixture of conjoined components and special general mixture, but a very good example is the prompt node there that you saw. Maybe you already noticed, but the prompt node itself had different ways of setting the prompt node up depending on what model you were using. So you can already imagine how difficult it was to figure out how to set up your prompt node the right way. So we went for very, very descriptive components. It's very clear, even from the name, what this component is supposed to do. The next thing we did, and this is my favorite, honestly, is a uniform interface. It really shouldn't matter what the component is doing. Building a component should be the same thing over and over again. There should be no surprises when you build a component for a pipeline. The next thing we did is make pipelines, the architecture of pipelines, a lot more powerful and flexible. So you saw this pipeline image so far where it's component going to the next component, but we made it so that they can now branch out, which was already possible, but they can also cycle. I'll show you why that's quite cool in a bit as well. Then we went ahead and released Haystack 2.0 on March 11th. And if you scan that QR code, I think it's going to stay up for a bit. It's actually our announcement article going through exactly what we changed and why we changed it, with the release notes attached as well. All right, so with that, I'm going to start by talking about how components changed. A component became a very simple interface for creating components the same way for whatever the component might be. And the most important thing is the number of inputs and outputs is completely user-defined. The pipeline shouldn't care. A component has a set of inputs, and a component produces a set of outputs. And the only requirements you have to create a component in Haystack 2.0 now is the following. Here, I've got a component very creatively called my custom component. And the only thing I needed to do is have a class called my custom component, have a decorator component around that class, and have a run function. all of the inputs to this run function automatically become the input to the component itself. And the component is expected to return a dictionary of outputs. In this case, I'm just returning documents. And this is a completely valid Haystack component, by the way. You could actually use this in a pipeline. It's just going to return documents, hi, bye. And the next thing we have to do, and this is really for pipeline validation down the line, is describe what the component outputs are and what their types are. This just makes sure that when we then attach this component to another one, that the input and output actually match. What this meant, my first favorite thing here is documentation bliss, as I call it. We went from having massive documentation pages for single components that do way more than they should. For example, here we have, again, the same prompt node. I've called it the God among nodes in this case. And I'm actually really happy to wait for this GIF to just scroll to the bottom. But this is, we recorded it 2 days ago. This is the entire documentation page of how exactly you have to set up prompt node in case you use Azure, in case you use Cohere, in case you use OpenAI, and so on and on and on. It went from this to being very, very specific. A single generator for a single model provider, how you use it on its own, how you use it in the pipeline, and that's it. So if I need to use Cohere, I just literally just go to Cohere generator. I don't have to scroll through how to set up a single pipeline specifically for Cohere. All right, so how then do we build pipelines in Haystack 2.0? So you saw before the whole add node situation that we had going on, where we were defining the inputs of a node, and then it was we were adding the next node and the next node. Let's assume that I have this component now. It's just called component. In this case, actually this is wrong. I should have fixed that. It's expecting 2 inputs and is supposed to be outputting 2 outputs, output 1 and output 2. And then the next one maybe could be another one called component 2, and it's expecting input 1 and input 2, and it's producing 2 outputs again. And the way I would connect these components, this is what's mainly changed in the way we operate pipelines, is, again, the same way as Haystack 1.x. We just initialize a pipeline, but instead of saying add node and adding a node and also connecting a node to the other being all in one line, we first add nodes with add component this time, and then we have a new pipeline.connect. And this is cool because this means we can be very, very, very specific about what output from what component is meant for what input in another. In this case, I've actually done a switcheroo. So component 1, output 1, goes to component 2, input 2, and then component 1, output 2, goes to the input 1 of the next one. This is cool because effectively what this means is I can have pipelines that do this. It's just a one-pass pipeline where information is being forwarded to the next. But I can also have pipelines where maybe one component has 2 inputs, 2 outputs, and I forward those 2 outputs to different components, and so on. So I can have branching pipelines. I can also easily have pipelines that have branches and loops, which is really nice because we've also seen that loops are quite cool if you need to do some checks, make sure an output is correct, and retry again and again until you have the right output. And because components are quite easy to implement now, it can also mean that, say, Haystack provides a bunch of components, but just not the one you need. You can just simply create your own and replace any component in the pipeline with yours wherever you need it. The next thing I want to talk about, which we didn't really discuss before, is document stores. So document stores used to be a mixture between being a node of a pipeline and something that another node could have access to, which got confusing in terms of developer experience sometimes. So we very much simplified that in that a document store or database is just basically a service that your pipeline in any stage of the pipeline can have access to. For example, a retriever might need to have access to the document store. So what can we build with this type of stuff? I've got some examples, and then hopefully I'm going to try to show you some demos if this works well. But for example, I could have a branching pipeline where I have a conditional router, and if the answer is valid, or sorry, the answer exists in your database, fine, you're good, I give you the answer. But if it doesn't exist in my database, then I can maybe route the pipeline to something that does web search, and then that does something with that. Maybe you can do hybrid search. So this, again, if you're familiar with NLP, maybe you'll know there's two types of retrieval. Some of them can be keyword-based, some of them can be embeddings-based or semantic search, and it's sometimes quite useful to mix these things up. We call this hybrid search, and then we join the documents and then base the retrieved documents on two types of search. This is great because now our pipeline can have branches, so I can maybe do hybrid search. The next thing, we actually have a tutorial on this, and if you scan the QR code, I think it takes you to this specific tutorial. This is a very good use case of looping pipelines. So in this use case, the idea was that we wanted to create structured outputs from completely unstructured text. And the way we can do that is maybe have a pydantic model of what we need the structured output to look like. But Haystack actually doesn't have an output validator component that can use a pydantic model. That's fine, we can just create one. We just need a component decorator around a class. And in this case, what's happening is once a generator generates some sort of structured output based on an instruction, the output validator can maybe say, yes, this is the right type of output, and you're done, you're good. Or it can say, no, this was not correct, and here's the error message, generator, retry. And it goes on and on and on until it gets it right. The good news is we do have maximum loops allowed, so you don't have to rack up a bill with OpenAI. Really, though, all of these use cases aside, these are very cool use cases. The most common thing we are definitely seeing, and this is actually a full Haystack way of building a retrieval-augmented generative pipeline, this is what we're seeing. We're seeing people use an embedder, which is a Haystack component that can create a vector from your query, and it does this with whatever model provider that you choose to use. Then a retriever that then retrieves documents from whatever database you want to use. In the Haystack world, we call this prompt builder. You can just simply think of this as building an instruction for a large language model. And then a generator that then queries a model provider and then produces, hopefully, an answer. All right, so I'm really hoping this works because I'm going to try to move a bunch of these screens to the next one to give you some examples of things that we built. And let me just get this out of the way. So the first thing I'm going to show you is if anyone has a Mastodon account and you feel brave, I can show you a demo we built, which I very tactfully called Should I Follow, which is a Haystack pipeline that, let's do this. Oh, it did work. That's nice. So this is based on a Haystack pipeline. My idea was maybe not very politically correct, but the idea is back in the day it was Twitter usernames. You can give it a Twitter username and it would give you a sort of vibe check of that account, and then you can decide whether you should follow them or not. Then things changed. Twitter got bought and the API changed, so I couldn't use Twitter anymore, so I switched it to Mastodon. Every time I've been doing this, I've been using my boyfriend's account, but he hasn't been posting recently, so it's really boring when I put his username in now. So if anyone wants to see what kind of things you've been posting about, I can have your Mastodon username, but let's try Ross's again. And I really hope it works. That's always the, ooh. Okay, so he has been posting lately. So there you go. This is what my Should I Follow application, the vibe check for my boyfriend's account, Mastodon account, is the following. All right, but how did we actually build this? There's a reason I wanted to show you this particular one. Haystack doesn't come with a component that can fetch a Mastodon user's posts. That's fine because the component building structure has been simplified so much. So this is quite a cool page. I can actually look for mine, Mastodon. This is actually my own contribution to Haystack. It's not actually owned by DeepStart or anything, but there's nothing stopping me from creating a component that might be useful for others, packaging it, then putting it up on this page. This is the Mastodon fetcher with instructions on how to use it. And it's packaged. You can just go ahead and install it, and it's a component usable with any Haystack pipeline at this point. And I just wanted to show you just how much code that actually took. Because here is the source code for my Mastodon fetcher, and that is literally it. So now we have a component that can be just slotted into any Haystack pipeline, given the inputs and outputs matching. Another one maybe that we can have a quick look at, because it was just published today by one of our colleagues. This is the auto quizzer. Again, this one also has lots of custom components, because it turns out that we don't have a component that can output a quiz in the exact structure this colleague wanted to have. But this is a demo where you can just provide a URL, and based on the contents of that URL, it's generating a quiz. It's just a five-question quiz with 4 answers possible. Then you can submit your answers and get a score. The cool thing is you can also then have large language models try your quiz. You can have a large language model try your quiz without looking at the web, see how they score, and you can also try with web search. This was quite funny because we decided to provide the URL of, I think it's the document store documentation of Haystack. Turns out that even with the web, Llama 3 got some questions wrong, so that was a bit sad, but hey. All right, with that, I'm going to hand back to Massi to talk about how we actually get these types of applications in front of people's eyes. And hopefully this works and it goes back. There you are.
Thank you. Okay, this wouldn't be an AI talk without talking about how do you deploy your AI application on production, right? However, I'm not going to tell you how to deploy Haystack on Kubernetes, because to me, this doesn't make sense as much as it doesn't make sense to deploy Django on Kubernetes. So I want to share more the philosophy behind the framework. And this is not about the goal, but this is about not about the destination, but it's about the journey, right? So we equip the framework in a way that it provides the tools that you need to go through this journey that you see on the slide. So you start with your pipeline as a prototype on your laptop, with or without GPU. It works. Next step, you want to share to a colleague or to some friends, same pipeline. You go and do like Tuana did with the Should I Follow demo. You have your self-hosted application based on Streamlit or Gradio, and all the way down to the moment where you decide to actually go on production. Again, same pipeline, this time on a production-grade environment where your application can be used by many users. Let me give you some examples of this philosophy, and I would like to start with this concept. At this point, it should be clear that pipelines are the core concept of the framework, and we really wanted them to be some sort of middleware in a way. So, for example, you can go from every pipeline can be serialized to a certain format that by default is YAML, and the other way around. This is a powerful concept because it works 2 ways, right? You can actually write and define your pipelines in a declarative way, writing YAML code, potentially without even knowing Python. You could actually write an Haystack pipeline without touching a single line of Python. And the other way around, so every pipeline that you define can be serialized to YAML and then sent over the wire, for example. Or you can store it in a database. You can have a catalog of pipelines stored somewhere. Or you can send this YAML representation from service to service, maybe to deploy your pipeline behind an HTTP service. And to stay faithful to Haystack philosophy, where everything is customizable, You don't even need to use YAML. If you want to use another format, all you have to do is to customize the marshaller and have, I don't know, using JSON as this intermediate language, for example. Another key point, right? You can't really claim to have a production-ready application if you don't know what's going on at any given time in your service. So what's the take at observability from the framework? The idea is that the framework provides you with the tools out of the box, and then it's up to you to combine those tools in the observability stack that makes more sense to you. So for example, right out of the box, Haystack can send APM data to Datadog or OpenTelemetry. We support structure logging through the struct-log library. We have LLM tracing. For example, out of the box, you can use LangFuse. And once again, you always have the option to override and customize the way the default tracer, the default logger, with your custom code and send data where it makes more sense to you. You already saw a glimpse of this concept of integrations. You can think about integration like they were plugins to extend Haystack functionalities. And the point here is that your framework is as production ready as any piece of code that you use to extend it, right? So you can't have the core production ready, but then the plugins that are not. And in our case, we have a curated list of integrations that we call core integrations because they are maintained by the developers at DeepSet. And each one of these integrations are supposed to extend Haystack in a meaningful way. They have their own release cycle. They are documented. They are showcased on the integrations page that also Tuana showed before. So it's about having a production-ready ecosystem. Another point that very often is overlooked, it's about trying not to break stuff. It sucks when you deploy something in production and then the framework gets updated and nothing works anymore. So we decided to commit to this. It's costly, but we really committed to this, and we defined this breaking change policy that you can find in our documentation, where the process to roll out breaking changes is detailed. And on top of this, if you check out our release notes, you will find how much love we put into them in order to tell you, hey, you want to upgrade to version 2.1.0, beware of this, that these are the steps you have to take to upgrade to the latest version. And last but not least, again, I don't think it makes sense to say how to deploy a framework somewhere, but still, we wanted to provide guidance to our users. So if you check out our documentation, there is this deployment guide section where we give blueprints and examples. It's mostly for inspiring the different ways you can have to deploy an AI application based on Haystack in a production environment. That was all I got. If you are interested, please give Haystack a spin. All you need is just pip install Haystack AI, and you will be in business. And before I stop, a little bit of public service announcements. If you like the idea of writing AI applications through the concept of pipelines and graphs, don't miss Tuana's talk on Saturday. She will go more in depth into this concept of pipelines with practical examples, right? So it's going to be hands-on. Ballroom A, Saturday, same time, 1:30. Last bit of PSA. Tomorrow evening, we have this AI happy hour together with the folks at DataStax. It's really about networking, right? Like if you are an AI enthusiast or you just want to meet people, please come, and there is no agenda, so I think it's very casual meeting. Only one favor to ask, the venue has limited seats, so please, if you intend to come, please register. You can scan the QR code. I leave this up, and that's it. Thank you. Oh, yeah, if you have any questions. Yes.
The two frameworks both really try to the most part, solve the same problem with a very different approach to how you do it. So Haystack, as you saw, is really based around very, very simple components and building pipelines around those components, whereas LangChain has a slightly different approach to this. So it's mostly about the developer experience and how much control you want to have on what your pipeline does and what each component of your pipeline does. The other thing is, we've noticed that pipelines are actually very, very powerful. So maybe you already started to notice, but pipelines can loop. And effectively, when you think about that, that means that a pipeline in itself can become a service that then invokes other things, other components, etc. This is a very different approach that we have. So pipelines in themselves have become agentic, if you know what that is. Maybe it rings a bell. Whereas the approach that LangChain takes to this, still very valid, is just a different way of thinking about it and approaching the problem. So I think it's a developer experience to the most part. But Massi, maybe you have a different answer. No? Okay. Yes. This is a very good question and very relevant to a lot of community questions recently, which Massi has lots of answers to. So I'm going to let you take it.
Yeah, about, let's get the easier one first, about caching. I think there are a few things that, a few services, if you like, that need to happen at the pipeline level. And document stores are actually a good example. It's not a node, it's not a component of a pipeline, it's just something that's available to the nodes of a pipeline. Caching, I think, could be very, very similar. Probably it would need a dedicated interface. We know some of our users are already using the concept of document store that was actually designed for abstracting away vector databases. They are using it to abstract caches or even agent memory. So probably it deserves its own dedicated interface, but yeah, it's something at the pipeline level, totally doable, supported by the design. About batching, specifically, if you are referring to running, so you go through, you visit the graph, and at some point you have a bunch of nodes at the same level. And if I understand correctly, you would like to run those nodes concurrently or in parallel, something like this? Yeah, so, yeah, okay, got it. Right now, components that can batch things, components that can saturate like your GPU, already take in input a list of things. The problem is that it depends on your pipeline. So if you have an indexing pipeline, you can put one of these nodes at the beginning of the pipeline, and you can just send as many batches of whatever size it works for you to the pipeline, all good. Problem is when your pipeline starts with a single input. So say you have a query pipeline, and now you want to batch this query pipeline, not batching, but say you want to evaluate the pipeline across different inputs. Now that's a problem, because at that point you have to orchestrate the execution of many pipelines, the same pipeline at different instances at the same time. To do, for example, and I think this is very, very dependent on the use case. If the use case is evaluation, for example, we just added, still not released, the concept of evaluation hardness, which stems exactly from this. I want to test this RAG pipeline across so many different queries, and this hardness system would orchestrate the pipeline for you so that the interface stays fairly simple, as much as it can be simple for in an evaluation system that's complex by its own. So yeah, batching happens at the component interface level. which doesn't always work, unfortunately.
I guess we didn't really touch on how we made this release in this presentation, but it was actually quite a long process that spanned many months, making sure that the community was aware of what was coming. So instead of having just a major release overnight, the thing we decided to do was, Haystack was actually in a different PyPI package. It was called farm-haystack. So what we did was we just announced to the community that there's this big rewrite planned. And we decided to separate that from everything. Correct me if I'm wrong, but the main reason was just how different the pipeline architecture was going to be. So it wasn't just about changing the component and then you can still use it in the old pipelines. The pipelines themselves was going to be changing so much. So what we decided to do to help the community, A, realize that this is happening, and B, also get a taste of it in the meantime, we had a pretty, 2-3 months, maybe even more, period of beta phase, we called it. So instead of having Haystack 2.0 overnight, we had a beta phase where people were able to still install Haystack AI, the new framework, test it out, try it out, understand it, and this took months and months and months, actually. And then we gave them a date as to when Haystack AI would have the stable release of the first Haystack 2.0, but we kept Farm Haystack. Actually, it's still available, and you can still use Haystack 1.25, 26, I don't remember which one was the last release. So we still see people using that if they haven't been able to do the migration themselves, and that package is not going to be impacted from Haystack 2.0. Yeah.
One thing to add on top of what Tuana said, even before the beta, we snuck the new code into the old package. So we created this preview package in the old version of the framework. And actually, sometime later, a colleague made me notice, oh, why didn't we call it from future? So you can do from future import pipeline. That was a missed opportunity, but actually the community could use the new code even way before the beta release.
I've actually not used the Neo4j document store myself much, so I also, just FYI, don't quote me on this. But the way I am aware that the document store has been implemented, it's the entire graph is provided as an entire document store. And this particular document store has some custom functions in itself, which I believe allows you to access individual nodes in your Neo4j graph. But don't quote me on it, and until my next talk, I'll actually check and let you know if you're there. Thank you.
Thank you.